All right, here's a couple of questions that deal with transformations and exponent log kind of things. So here's a question where they're giving you a square root function and they want to know how it's different than this function. And so if we look at how normal functions, or the four transformations for normal functions, I look at this, and that's in the a spot in front of the function. And so that a, the function of that is to reflect, or if it's negative, it reflects the graph on the x-axis. So it flips it upside down. With that one, the normal square root function looks like this. And so if it flips it on the x-axis, it would, this is the x-axis here, it would go look like that, something like that. Okay, and then the next point, this 7 here, is in the C spot, and whatever the sign is, it's opposite to that direction, so it's not right, it's going to be left. So that 7 tells me that I need to go left 7. So it'd be the same graph as this red one, except it would be 7 over to the left. 3, 4, 5, 6, 7, so the graph would look something like that. Okay, so that's what you need to say. Really, you just need to say it moves left 7 and it's reflected on the x-axis. All right, this is a similar kind of question. It says graph the function by plotting points and state the transformation. Well, right away I can say that the transformation is that the graph moves right 2. So if I know what the log graph looks like, and the log graph looks like this, where the y-axis is the asymptote, where that graph gets closer and closer to it but never touches, and it goes through 1 right there. Those are characteristics of all log graphs or lawn graphs, and then it gets moved to the right too. So if it gets moved right too, so it's going to go through here. So this line 2 is going to be the asymptote, so the graph will look like that. Okay, now it says by plotting points. Another thing you could do is plug in values for x and y. So say plug in 0 for x. If you put a 0 in there and then figure out what that is, I think that'll come out undefined. If you put a 1, it'll be undefined. If you put a 2, it'll be undefined. If you put a 3, it'll come out to 0. And then 4, it'll come out to, like, that'll be ln of 4 minus 2, or the ln of 2, and the ln of 2 comes out to 0.7 or 8 or something like that. And then put a 5 in, etc. And you can get what those points look like. Okay, last question is a log equation. This is a great question to know how to do. So the first thing you need to do is to squish these two logarithms. And you can do that according to the product rule. I know it's product because there's a plus there. So I can squish them and write only one log, and then I take the product of the two things you're taking the log of. So, whoops, x plus 3, x minus 3 is equal to 3. So there I've squished the two logs. Then I change it from log form to exponential form. So here's my base. So 2 to the third is equal to this, x plus 3, x minus 3. So 2 cubes 8. Let's FOIL this together. So it'll be x squared minus 3x plus 3x minus 9. So that's x squared. Those cancel. Minus 9 equals 8. And now, usually if it's a quadratic, I bring everything to the right side. But if there's no x term, it might be easier to use the square root principle. So I'll add 9 to both sides, and then I'll take the square root. So x is a plus or minus square root of 17. Now, if I plug in a minus root 17 in for x, if I plug that in either one of those, that gives me the log of a negative number, and that can't happen. So x can't be equal to negative root 17, so it only is going to be a positive root 17. So my only answer is x equals root 17. All right, hopefully that helps you with those 3 questions.